In this video, we'll be looking at our 7th grade math review, week 19, days 3 and 4. The first part of day 3 is dealing with operations on integers, signed numbers. We have some add, subtract, multiply, and divide. Remember our rule for multiplication and division. If the signs are same, the result is positive. If the signs are different, the result is negative. For instance, negative 8 times negative 6, two negatives, the product is positive. Compared with this one, 75 divide negative 3, in this case the signs are different. So the result, the quotient in this case, is negative. When we're dealing with addition and subtraction, we have a rule for addition. The addition rule says if the signs are the same, we add them up and leave the sign the same. So 12 negatives plus 8 negatives is 20 negatives. That makes perfect sense. 12 negatives and 8 negatives, 20 negatives. Remember, you can think of a negative number like owing money. If you owe $12 and you owe $8, you owe $20. Okay. If the signs are different, we will subtract the numbers. So in the case of this addition here, I'm going to do one like this one, and you can do this one. Let's say I had 20 plus a negative 7. When the signs are different, you subtract the numbers, the absolute value of the numbers. That is, you don't worry about the signs. 20 minus 7 is 13. Then you consider which one has the larger absolute value. 20 is a larger absolute value than negative 7. That is, there are more positives than negatives in this case, so the result should be positive. If I have $20 but I owe somebody else 7, really I have $13. Okay. Now, if we have a subtraction in between, we must get an addition in between and then use the addition rules we just mentioned. And we do that by keep, change, change. Keep the first number the same, change the subtraction to an addition, and change the sign of the term behind the subtraction. So negative 18 minus negative 7 is the same as negative 18 plus positive 7. So again, we're going to subtract the absolute values. 18 minus 7 is 11. And since there are more negatives, we will keep that. Again, back to the thinking about the negative number being owing money. If I have $5 and then I subtract owing some money, okay, if I take away that I owe, isn't that the same as getting money? So this would be this statement is equivalent to 5 plus positive 3. If I have $5, but then I owe 3, but if somebody says, no, you no longer owe that, I'm taking away that you owe, that's gaining. 5 plus 3 is 8. 5 subtract negative 3 is the same as 5 plus positive 3, or 8. Okay. Next group. It says solve each inequality, then draw on the number line. I'm going to show this first one. We have x plus 9 is greater than negative 23. I want to solve for x. I want to get down to this x. Currently 9 is being added to it. I need to undo that plus 9 by subtracting 9. Whatever I do to one side, I do to the other. 9 subtracts 9 to leave x. We preserve the inequality. Negative 23 minus 9, that's the same as negative 23 plus a negative 9. That's a negative 32. Now I can graph this inequality. 0 in the middle. Negative 32 would be on the left. And I'm going to put one value on the right. I'll go with positive 32. Alright, I want values greater than negative 32. That's to the right. Alright, and since there's no equal to with our inequality, we will have an open point. I'm going to shade values this direction. This number line, this shaded number line, is an equivalent statement to this. This is saying x is greater than negative 2. The number line is shading values greater than negative 2. Alright. In a similar fashion, you could solve these equalities down here at the bottom. Okay, now on to day 4. It says simplifying, we have some power expressions, that is numbers taken to some exponent. 7 to the third, another way to say 7 to the third is to say 7 times 7 times 7. It's this number multiplied by itself that many times. 7 times 7 is 49. 49 times 7, well, let's come over to the side and do some multiplication. 7 times 9 is 63, carry my 6. 28 and 6 is 34. So 7 cubed, we say, or 7 to the third power is equal to 343. See if you can answer the rest of those. Fill in the boxes and write a rule. Here we see 0 is going to 6, 4 is going to 10. It appears as though we're adding 6. 4 plus 6 is 10, 0 plus 6 is 6. So our function rule here is y equals x plus 6. If we take our x value and add 6 to it, we will yield our y value. Alright, see if you can use what we did. Oh, let's fill out the rest of the table as it says. Substituting 6 in place of x. 6 plus 6 is 12. When x is 6, y is 12. Substituting 22 in place of x. 22 plus 6 is 28. When x is 22, y is 28. Now this time 113 is y. Well, if we added 6 to go this way, I hope that you can tell we should subtract 6 to go this way. It'll be 107. Now I'm going to show it algebraically over here. We had y equals x plus 6. In this case, we know the y value. I'm going to substitute 113 in place of y. 113 is going to go here in place of y. So new statement. Instead of y, I have 113 equals x plus 6. I want to solve for x. So I need to undo this plus 6. The inverse of addition is subtraction. So here you can see exactly what we said. It's 113 minus 6. On this side, 6 subtract 6 to leave x. 113 minus 6 is 107. Indeed, what we knew it to be. Alright, with that information, you should be able to handle the rest of those.